So we're going to stay with today's solving more equations because that's what math is all about. We've got some equation that models something in the real world and we want to solve, we want to get the answer. So let's jump right into it with example 1. What we have here is an equation, obviously, because we can see the equal sign. And so we have two sides to this equation. And I'm going to work the two-side method. I'm going to work it so that I get all my variables on one side and then all my constants or just numbers on the other side. So the first thing I have to do is follow my order of operations. So as I start reading from left to right, I see 3 times this quantity. So that's right, we're going to distribute and we're going to triple everybody in the parentheses. So x becomes 3x and 2 becomes 6. All right, continue reading. -2, it wants me to double everything in this parentheses and negate it. So x becomes -2x, and 7 becomes -14. And then on the other side, on the right side, we have 4x plus 7. We don't have any work to do. So now give me a second here. I'm going to clean this up. And I'm going to bring out everything, but I did a little something special with them. Let me ungroup them and show you what I did. Everybody's an individual now. So I'm going to look here. This 3x, is that a variable? Yes, because it's got a letter, so it gets to stay on this side. The plus 6, is that a variable? No, it's a constant. So it moves to the other side, but as soon as it passes over the red line, watch what happens. It changes to a negative. The -2x, is that a variable? Yes, so it can stay on this side. The -14, is that a variable? No, it's a constant. So once again, it's going to go across the magic line, and when it goes across the magic line, we do its inverse operation, so it changes to +14. Okay, now let's look on the other side. 4x. Is 4x a constant? No, it's a variable, so it has to go to the other side. As soon as it crosses this line, it changes sign. All right, so what we have now is we have everything. These are all variables. These are all numbers. Let's see what we get. 3x's, take away 2x's is 1x. Take away 4x's is -3x. And then over here, 7 minus 6 is 1, plus 14 is 15. Okay, now we can just solve it with one more inverse operation. Since this is being multiplied, we will divide by -3. My variable of x equals -5. All right, and I'm just going to show you on Desmos, again, how we could have solved this using a graphing calculator. So, it's getting a little busy here. Let me clean this up. We know our answer is x value is -5. So that means if I enter this as one equation, and then in the second line, enter that, I'm trying to see where this line crosses this line, because they're both linear equations, and here's the picture. There it is, in red is the left side, and here in blue is the right side. And then if I come over here and look, That's where they cross, where the x value is -5. Now notice there's a y value here of -13, but there is no y value over here. So we're not really worried about the y values. They were only asking us what are the x values. All right, let's try this one. I'm going to use the same approach. So I like to shoot a line down the middle. Whoop. And I want to move everything so that the variables, I like my variables on the left. They don't have to be on the left. I just like them on the left. And my constants are on the right. All right, so let's start reading. 5x. All right, nothing we can do with 5x, so that gets to come down. -2 times. Oh, so they want me to double and negate everybody in this parentheses, better known as distribute. So -2x minus 2 equals, and what do they want me to do on the right side? Oh, they want me to double everybody in parentheses. So that's 2x plus 8. Great. Same thing's going to happen. I am going to clean this up for you so that everybody can move individually. 5x is a variable. Congratulations, you get to stay on the left side. -2x is a variable. Congratulations, you get to stay on the left side. -2, you're not a variable, you're a constant. So you have to do an inverse operation and move to the other side. So that -2 is going to come over here as a +2. Moving to the right side, 2x. Is 2x a constant? No, it's a variable. So we have to do an inverse operation to move it to the other side. Since it's a +2x, its inverse is going to turn into -2x. There, we have it. We've got all our variables on one side. We've got all our constants on the other. Okay, math time. 5x's, take away 2x's is 3x's. Take away another 2x. This all boils down to a single x. We love when that happens. And what do we have over here? 8 plus 2 is 10. So we're saying our answer is x equals 10. All right, so now instead of checking this on Desmos, I'm going to check it by hand. So that means I'm going to put a 10 in every time I see an x. 5 times 10 minus 2 quantity. All right, there's an x. I got to put a 10 in there. Plus 1. And then over here, 2 times, oh, there's an x. I'm going to put a 10 in there. Plus 4. All right, 5 times 10 is 50. Minus, I can't do 2 times. I got to do my parentheses first. So 10 plus 1 is 11. All right, so that's 50 minus, okay, now I can multiply. 2 times 11 is 22. 50 minus 22, well, 50 minus 20 is 30. Take away 2 more is 28. So I better get 28 over on this side. Do my parentheses first. 10 plus 4 is 14. 2 times 14 is 28. Great. My answer of x equals 10 checked out. Okay, one last example for the day. All right, there's my border. And by now we should be pretty adept at this, so let's start reading left to right. 7x, nothing's happening with you. Plus 2 times, oh, they want me to double everybody in these parentheses, so plus 2x plus 10. And then over here we have 9x plus 10. All right, let's start moving things around. Or some of you may notice something. So I'm actually going to leave this up here, but then I'm going to move everything around like I was doing before. All right, so once again, variables get to stay on the left. So 7x, you get to stay on the left. Positive 2x, you get to stay on the left. But 10, you're a number. So over the magic inverse line you go, and you switch from a positive 10 to a negative 10. Now 9x, You're a variable, so over the magic inverse line you go. You have to switch from a positive 9x to a negative 9x. All right, let's clean things up here. 7 plus 2 is 9x. Take away 9x is 0. Wait. They were variables. Now there's just a constant of 0. Okay, let's not panic. 10 take away 10 is 0. 0 equals 0. Well, that is a true statement. But is my answer x equals 0? I don't know. Let's look at Desmos for a second here. When we bring out Desmos and we put on the red line 7 plus 2x plus 10, and we put 9x plus 10 on the blue line, well, over here I only see a blue line. So where's the 7 plus 2x plus 5? Well, I'm going to shut off the blue line. There's a red line. There's a blue line. There's a red line. There's a blue line. There's a red line. There's a blue line. Shut off the red. There's a blue. They're on top of each other. Oh, you guys just saw a really cool example. The answer here is all real numbers. That's how you draw every number in the world. See what I did? I drew the letter R. I kind of extended its top, and then I put an extra back on the letter R. So that is all real numbers. In other words, since you came up with a true statement right here, every number in the world works. No matter what you put in for x, it will work. X can be 3, x can be 2, x can be 1, x can be 1/4, x can be 0.5982, x can be the square root of 3. No matter what you put in there, it works because the lines are on top of each other. You might have noticed that up here. Again, let me clean all this up. And right here, you might have noticed that 7x plus 2x is 9x plus 10, which is the same as 9x plus 10. So really, these were the same lines, just one was hidden. So when you have a true statement, all reals are the answer. I'm going to leave you to think about, what if you have a false statement? What do you think the answer is if you come up with a false statement? Talk about that tomorrow in class. Bye.